This session is the continuation for the decision tree classifier model that we are going to will build for a classification problem. So this is, I hope you have watched my previous video. So I had stopped over here in the data pre-processing. So let's start with the data pre-processing. So we have taken care of outliers in our data set. So let's do data pre-processing. So let me show you the data set first. So you see, this is the data set that we have, and in this data set, we can see that job, marital, education, default, housing, loan, contact, month, and P outcome and deposit are categorical variables. Okay, I mean we have to convert into numerical ones because we want to process our data. For that we need to be having our data in numerical format. So let's do encoding first. So we have actually imported as from sklearn, we have imported pre-processing. So let's do the encoding part. So define preprocessor, define preprocessor of, let's pass the data frame over here. So here's our function. So resultant, let's return the resultant data frame. So let's pass it. So before returning the resultant data frame, we have to make sure that we have to perform some label encoding on the current data frame. So let's pass data frame dot copy over here. Okay. So so let's assign the pre-label encoder to LE. So pre-processing. So we have imported pre-processing. So pre-processing dot label encoder. So now what we will do is that, so this is our resultant data frame, right? So in the resultant data frame, we have copied the data frame. What's the data frame? Let me show you the data frame. Df dot head. So this is the data frame. So now what I will do is, so I will do the label encoding for a job, marital, education, default. So wherever there are categorical variables, wherever there are category present in the column, let's do label encoding on that columns. So resultant data frame is of, let's pass a job first. So job is equal to LE. LE is our label encoder dot fit transform. So we do fit transform so that we are converting our data into categorical into numerical one. So we will have technician, retired, blue collars, whatever category that is present here. So there is unique values that will be given so that we can process the data. So LE dot fit transform of resultant data frame of job. Similarly, they have to perform this operation for marital, education, other categorical variables as well. So let me copy this. So let me change the values over here. Here, instead of job, here you have to take marital here as well. Then you have to take education. Then we have default. Next, we have housing. Next is loan. Similarly, we will consider for loan as well. So we have now used loan variable, loan column as well. So now we will do the fit transform for contact, and let's change using label encoder for contact variable contact column as well. So now we will consider month column. Month column also needs to be changed where we want numerical values for month as well. And also we will be changing the P outcome. So P outcome also will perform label encoding. P outcome. Similarly, next we have the last one, which is a dependent variable. So we will consider for deposit as well. So what we have done is here we have done the pre-processing data pre-processing. So what kind of pre-processing do we have done? We have transformed the categorical column into a numerical one using label encoder. Okay. So once you have the resultant data frame, you will return resultant data frame. So now let's pass the data frame over here. So let's give the variable name as encoded data frame is equal to preprocessor, which is our function name. Preprocessor is our function name, and we are passing the data frame over here. So now let's print the encoded data frame dot head of, let's print the first two rows. Okay. So if you see this, you can see all the categorical variable that we have, that categorical column that we have now converted into a numerical one. Could see that. So once we have the numerical, once we have done the pre-processing, now we separate the dependent and independent variables, that is dependent and independent columns or variables. So here the deposit is the dependent one, and other columns that are present in our data set is the independent variable. So let's call X, the variable name X is encoded data frame dot, let's drop only the deposit column. So df of deposit. And so we have passed data frame, right? Encoded data frame dot drop of what's the column name, that is deposit, and we have passing axis is equal to 1, because axis is equal to 0 means we are actually dropping the rows, right? So in our case we want to drop the column, that is the deposit column, so you have to pass axis is equal to 1. And then what you can do is that let's print this and check out what's the values of X. So we have got the dependent variables, independent variables. So let's take the values. So let's take dot values. So we will get an array. Okay, we'll get an array. Let's print it out. Okay, so we have an array. So now similarly, what you can do is that let's take the dependent variable now, encoded data frame of, only we want deposit column, which is our dependent variable, dot values. Okay, so now let's print y as well. Let's see what's the value we get. Okay, so we have our dependent variable here. So now we have an x and y. So now what we will do is let's split the data into training and testing data sets. Okay, so we have x train. So we have x train, comma x test, comma y train, comma y test is equal to, we perform train test bit So we have, so you could see that from model scale and model section, we have imported test list. This is used for splitting the data. So let's split. So let's pass X, the dependent variable predictors, and Y. And let's pass the training size or test size. Let's pass. So test size, we will pass it as zero point 0.2. So 20% of the data is considered as test size. And let's pass random state as well. So random state, do we need? So it's your wish to give random state, but what we'll do is that let's give random state or not. Let's not give random state for now. You can give it, but no worries. So let me call this as splitting data, splitting data into train and test. So now we will build the build decision tree model. Okay, so we have done the splitting part over here. So let's build decision tree. So our main goal was to build a decision tree. Let's do that. Building decision tree model. Okay. So what we'll do is that let's build a decision tree with the depth, max depth as 2. Okay. So model decision tree is equal to decision tree classifier, decision tree classifier. So we will pass random state over here. So you need to pass random set so that when you run the same, when you run this code again, so the data sets remains same. Or so let's pass random state is equal to 1, and maximum depth let's consider as max depth. So why we are passing random state is equal to 1 is you will understand in the next, when we give maximum depth, when we change the maximum depth to other value. So we have passed maximum depth as 2. So now what we will do, we'll do the training of model. So we have to train the model. So model decision tree dot fit of, so we have to train our model x train comma y train. So the training is done over here. So now what you have to do is we have to calculate the score. Score is nothing but the training accuracy. So print model dt dot, what we will do, will pass score model dt to score of. So now let's print the training accuracy. So let's pass x train and y train. So whatever x train output you will get, that will be compared with the y train. And similarly, you have to pass model decision tree underscore decision tree dot score of x test comma y test. Okay. So let's see the accuracy. Okay. So what you can do is that you can pass random state over here so that training and testing data are splitted in such a way that when you run the code again, it will be constant. Okay. The same split happens once again. Okay. So now the training accuracy is 80% and the testing accuracy is 81%. Um, so for maximum depth of 2, the training accuracy and testing accuracy are almost same. Okay, so now what we will do is that now let's see, and now let's build a model where maximum depth is 4. Okay, so now let's run this code again. So for for a maximum depth of 4, we can see that the accuracy has improved. So this is better model compared to the previous one where maximum depth was 2. So similarly, now what we will do is that now let's take maximum depth is equal to 6. Now let's take maximum depth is equal to 6 and check the output. Okay, so we could see that the difference between the training and the testing accuracy is almost 10%. So we can say that there is some kind of, hold on a second. So we have got the difference of 10% between my training and testing accuracy. This is not a good model because the training accuracy should almost be the testing accuracy should almost be equal to the training accuracy. Similarly, what we'll do, let's see the accuracy score when our maximum depth is 8. So this is a poor model when the maximum depth is 8. So you can consider the model where maximum depth is 4. This is giving the best results with training accuracy as 87% and testing accuracy is around 83%. So now what we will do, so what happens is that in decision tree classifier, so we have considered criterion to be Gini, okay? So this is by default is it is Gini. So you can consider entropy as well. So let's take entropy decision tree with C 4.5 entropy. So this is nothing but the algorithms that were there like CART, C 4.5, D3, and child. Okay. So this is entropy C 4.5. So what we'll do now is that let's build a decision model decision tree is equal to decision tree classifier. So we have a decision tree classifier. So now what we will do is that let's pass maximum depth as 2, maximum depth as C. Let's see the parameters that are present in our decision tree classifier first. So maximum depth, we have passed it as 2, and we will be passing the criterion as entropy. Criterion is equal to entropy. Okay, now let's train our model. So we'll train using model.fit of let's pass x train, comma y train. So now let's predict. So now let's see the accuracy score. Model dot print. Let's print the accuracy score. Print a model. This is model underscore decision tree. So model underscore decision tree dot score of X train. We have to pass both X train and Y train. So whatever the X train output you get, it will come. It will do the validation with the Y train, and you get around 10-80%. So you could see that the training accuracy is almost same for a model for our model when you consider both criterion is equal to entropy or Gini with maximum depth as 2. So let's pass X test, comma Y test. So now let's run this. Okay. So you see um, the accuracy score for training is 80 and testing is 83. For criterion is equal to entropy, and it is 80 and 81 in case of Genie. Now let's take maximum depth is 4. Let's take maximum depth as 4. Check what's the accuracy score that you will get. So you could see the accuracy is 86% and 86% respectively for both training and testing. But in case of Genie, it is 87 and 83. So we can say that the entropy is performing better over here when considering maximum depth as 4. So let's pass maximum depth as 8. Yeah, 6. Let's pass it as 8 and just check. So maximum depth of 8 is giving some overfit. We have overfitting with the maximum depth of 8. Let's see with 6. 6 is giving better result, but the testing accuracy has decreased. So we could say that a maximum depth of 4 is a better gives better result when the criterion is entropy. Okay. So now what we do is that let's do so for our data set we can say that the criterion is entropy and maximum depth is 4. When these two happens, then our model is giving a better accuracy for training as well as testing the data. So you could see that the percent of accuracy percentage is almost similar in case of testing and training data set. So now what we will do is graphical representation of tree. So let's do the graphical representation of tree. So now what we'll do is that we will draw a decision tree with depth, okay, with some depths. So let's see that. So for that, first we have to pip install GraphViz, okay? Pip install GraphViz. So let's let it install first. So now since we have installed GraphViz from IO, import string input output, string IO, okay? Let's run this. Okay, so now let's plot figure. So plt dot figure. So we pass figure size here. Plt dot figure. If we pass figure size is equal to, let's have 10,8, and let's assign string about to dot data. So we are assigning our string IO to dot data here. So now what we will do is that we will use export GraphViz, and this is the function we for plotting the graph. Okay, so we will pass the model decision tree 8. So model decision tree 8 is nothing but where the depth is 8. So let's take this one, model decision tree depth 8. So model decision tree 8, we will consider this. 8, 8, okay. So we will consider this model decision tree 8 because we have the maximum depth of 8. So now pass out file. So let's see the parameters that are present in our export graph is. So let's try to pass parameters out file is equal to, let's pass string IO, that is dot underscore data, which is assigned to dot underscore data. So let's fill it with the data. So we will call filled is true and rounded. So we will round off the values is also equal to true. And we want special characters as well. So we'll pass special characters is equal to true. Okay. So now let's run and check. So name export graph is not defined. Yeah. So we have to define export graph is first. So let's define that first. So we have mentioned Conda install GraphViz over here. So that GraphViz export graph is defined. So it will take some time. So it's taking a long time for installing GraphViz. So let's move to the next part. So what you have to do is that just run the code once you install GraphViz. So after this, you have to uh, pass. You just assign graph is equal to pi dot plus. So pi dot plus dot graph from dot data, and you have to pass dot data get value. Okay. After this, you just have to write image of graph dot create underscore png. So run this code once. Uh, so let me just stop the kernel over here. Kernel. So wait a second. So we have interrupted the kernel over here. So go to kernel and interrupt if anything it takes a lot of time. So I want you to run this code on your own. So I'm going to continue with the next topic in this decision tree. So now what you have to do is that we have to see the performance. Okay. So what you can do is that see the performance matrix. So let's run it. So so we'll see the ROC curve. Okay. So we'll pass false positive rate underscore decision tree, false positive rate of decision tree, TPR true positive rate of decision tree, comma underscore is equal to ROC curve of. So we have to pass Y test comma Y prediction. So we have to consider Y prediction data as well. So let's see Y prediction data for maximum depth is equal to 2. Okay. So we'll consider maximum depth of 4. Actually, so our model is giving good results for a maximum depth of 4 for entropy, right? So what you can do here is that, so for this model decision tree dot underscore 4, here also you have to take underscore 4, and here also, and here as well. So on this, so 8684.5. So we will calculate the prediction. Okay. So for this, let's calculate y test y prediction decision tree. So y prediction decision tree is equal to model decision tree dot predict proba of pass X test. So here you will pass X test, and now you have to access the column which is the first column. Okay, so let's run this again. So 86 and 87 accuracy fine. So now let's pass Y test, Y prediction probability, Y prediction decision tree. Okay, so we have our Y prediction decision tree over here. So now let's see the ROC area under the curve. ROC AUC ROC AUC decision tree is equal to area under curve of false positive rate decision tree comma true positive rate decision tree. So this will give the score. Okay, area under the curve. This will provide. Okay, so let's. So what we'll do now is that. So let's do the prediction for X test. So predictions is equal to model underscore decision tree underscore score. Consider for that of X test. So now a print model decision tree 4 dot score. So this will give the accuracy score of X test comma Y test. So we already know that. So we got some error over here. Let me check it. Our prediction model decision tree of X test. Model decision tree underscore 4 of what the problem. We have passed X test and Y test over here. So model decision tree 4. This is our model decision tree 4, right? So let's run this code again. Decision tree classifier object is not callable. Okay. What we can do is that let's run this code. So accuracy is almost 87%. Okay. So now what you have to do is that. So we will call predictions is equal to this thing. Model decision tree of X test. Let's check if we get same output or not. So we have to do the model dot predict. So the problem was here is that we had to pass dot predict. So print predictions. So print predictions. So these are the predictions of the model for X test data. Now what we will do is that, so we had our encoded data frame, right? So here is our encoded data frame that we had created. Okay. So uh, let's take this encoded data frame to target that is already there, right? So encoded data frame. So X is an encoded data frame without target, and Y is an encoded target data frame with target. Okay, so let's pass print uh, print Y. So you could see that the values of Y is here. So these are the values of Y, and this is our predictions for our test data. So let's pass like X of test data. So what's X of test data? So now let's draw the area under curve. So I have the code over here. So for area under curve, so So we have plotted false positive rate against true positive rate, and we have given the color as orange for our plot, and we have labeled decision tree where ROC is a decision tree. We have a ROC area under curve. Okay, so we have to pass x limit is from 0 to 1 and y limit is from 0 to 1.05. So x label is false positive rate and y label is true positive rate. So title we have given area under the curve and legend. So legend is this area under the curve, right? Decision tree area under curve is till point two floating values we want. So we will plot that in the lower right. Okay. So this is the area under the curve we got. So we have an area under the curve of 81%, which is bit low comparatively. So you can increase this value by taking some other decision tree depth. So based on some other criterion as well. So you can do this and improve the area under the curve. Okay. So your task will be from here. So draw the confusion matrix. So check the false positive rate, true positive rate, and false negative and true negative. And then what you can do is that then draw the heat map for the confusion matrix. Okay. So I hope you will be able to do this thing. I have already taught you the confusion matrix in the previous sessions. So you just have to pass print confusion matrix of y test, y prediction. So then you will get the confusion matrix and you can take the accuracy of y test and y predictions to get the accuracy. Then what you can do here is you can plot Fourier y test, y prediction heat map for the confusion matrix. Okay. I hope you understood the session. Thank you for attending the session. I will continue with the next session about random forest.